me just explain. There is a server and there is a client. This client is running in your browser, the browser we just saw. So when I started the Jupyter Notebook on my computer, you might have noticed that there was a window like this. There was a window. I'll just show you that window was, the window was here. I will just show you. It is like this. This is the window. Now this window, if you see, it is written here, to access the notebook, open this file in a browser. We open it. Let me just do it again. I can just copy it, this file, or I can copy and paste this. So this token, if you notice, if I paste it in a window, the same thing has opened. So this is the client, and what I had shown you earlier was the server. So now when I do a new over here, and when I do Python this thing, so now I have got a console in front of me. This console is there, you might have noted. Yeah. Now this is the console. Whenever now this console, this page can be used to run a Python program. Now what is happening is that, suppose let me write something. Let me write print, or let me write 2 plus 3. Let me write 2 plus 3. So all of you can see this is the this thing I've written 2 plus 3 over here. This is 2 plus 3 I've written. Now when I run this, I get an output of 5. So as you can see, this is this 2 plus 3 I put over here, and I get an output of 5. So you might be thinking that I am going fast or I am going ahead, but let me just explain the user interface of this web page. Now this web page is the client, and whatever I type in this is called a cell. So this thing is a cell. Whatever I type over here, and when I say run, then what happens is that whatever script I've written over there is run by the server, and the output is printed back over here. So when I did 2 plus 3, sorry, wait. There was a mistake. I'll just explain. When I write 2 plus 3 and I run, so what happened? Now this 2 plus 3, which I put in this cell, this 2 plus 3 was sent by this browser to the server, which is running on my machine, and the server gave back a reply of 5, right? So you need to understand that this is and the server is running on the local machine. You can make out, because if you look in the browser, you will see local host. You can see it is written local host 8889. So if you are familiar, this means that this browser page is accessing a server which is running on my laptop. However, if you go to a page like Google Colab, let me open Google Colab. Where is that? Yeah. Now, when you look at Google Colab, you will see that the URL here is not localhost, but collab.research.google. So let me open this page again for you. Let me open a new tab. Let me write Google Colab, GOOGLE, enter, and I get this thing. So now I'm getting welcome to Google Colab, new notebook. So let me open a new notebook. Just one sec, it is opening. Yeah. So Google Colab, yeah. Now if you let us compare, this is the screen on Google Colab. It is written untitled 2.ipynb. Now, ipynb is the extension for a Google Notebook. And if I see this one, it is localhost, and this is also untitled 19. So what is happening is that this particular page, where it is localhost, this is running on the server is running on my laptop. However, on this page, the server is running on the Google website, or the it's a Google server. And here it is my local server. And suppose here also I print 2 plus 3, wait, 2 plus 3, and I do run. It will take some time because the data is going to the server of Google, and see, it is 5. If I, for those, just to make it more visible. So you see, I put 2 plus 3 over here. This is 2 plus 3, and I got the output 5. The difference is that when I'm using Google Colab, the server running Python is on the Google server. But when I'm running my own Jupyter Notebook on my this thing, then the server is running on my local machine. So Balaji, let me stop over here. Are the things clear so far? Is there any question, or am I audible? Am I visible? Am I understandable?
Audible and visible, sir.
Okay.
And we'll have the question answer sessions at the end of it. Otherwise, there will be a lot of noise in between, because there are a lot of people are on YouTube and they won't be able to listen.
All right. So the point I'm trying to make is that for somebody who's a newbie, the concept is very important, that you should understand that whenever you're running a Jupyter Notebook, you can run it on your local machine also, or you can run it.
Sir, you need to unmute yourself. Just a second, okay?
Yeah. If you want to do anything meaningful in Python, then you have to work on the Jupyter Notebook by running it on your local machine rather than on Colab, because Colab will not allow many things which you can do on the local notebook. So from now onwards, I will be working on the Jupyter Notebook. So let me just explain the user interface of this, right? So if you see the user interface, this is File, Edit, View, Insert, Cell, Kernel, Widgets, and Help. So File, Edit, View, Insert, Cell, Kernel, Widgets, and Help. So these are some of the menus on this thing. And then there are some icons also. I will not go through the icons. One important icon is this icon, this code. This icon is very important. Other, of course, is run. So these two icons are important, code and run. Let me explain. So when I click on this code, I get 4 options, code, markdown, raw NB convert, and heading. So let me talk about markdown. Now markdown is similar to what is called markup. So basically it is a version of HTML. So when I write this thing, for example, if I do H1 and I run this, so basically it is for writing markdown. So we will not go so much into it. And if I convert it into code, then it becomes a regular code window. So important thing for you to know is that to run Python, this should have code and not any of these other options. So code is there, right? That much is clear. Okay, so now let me go through the rest of the presentation. So right now, let us talk about some of these things. So I mentioned to you that Python, if you remember, the things I mentioned first was compiled versus interpreted. So Python is a interpreted language. It is not a compiled language. The second concept was free and open source. So Python is a free and open source language. I'll explain these concepts. The third concept was that Python is portable. The fourth concept was that Python is dynamic typing. And the fifth concept was that it has automatic memory management. So let me repeat these concepts once again. So first number is it is interpreted as opposed to compiled. It is free and open source as opposed to proprietary language. It is portable. It is dynamic typing, and it is automatic memory management. So these are the 1, 2, 3, 4, and 5 qualities of Python. Let's go over them one by one. So let us go to first one. Compiler versus interpreter. So Python is a high-level language. And to translate the high-level language into machine-readable form, two types of programs are there. They are interpreters and compiler. You need to understand that when you write something, a code, this code cannot be understood by the machine, by the computer. So there are two ways in this the code can understand. One is by an interpreter, and the other is via compiler. So interpreter and compiler are the two ways in which the code can be understood. So the languages which use an interpreter are called scripted languages. Scripted, S-C-R-I-P, scripted languages. And the best example of a scripted language is what is called JavaScript. JavaScript. And Python is also a scripted language. In fact, there was a very popular but very old scripted language called VBA, which is still used in Excel. So if you're using Excel, you can create macros using VBA. But we will not talk about VBA, we will not talk about JavaScript. The point I'm trying to make is that Python is an interpreted language. An interpreter reads the high-level language and executes the statement one at a time. With this, I'll make it clear. A compiler, on the other hand, reads the entire program, also called the source code, and converts it into a machine-readable form called object code, and then executes the entire program in one go. So therefore, in an interpreted language, if you write 5 lines of code, the interpreter will execute each one of them one by one without looking at the other 4. So if statement number 1 comes, it will execute that. Then it will execute statement number 2. Then it will execute statement number 3, then 4, then 5, and so on. However, in a compiled language, all the 5 statements will have to be first compiled into what is called a compiled output. And then that output is run by the executor. So if you look into a diagram, the two will look something like this. In an interpreted language, there's a source code or the script, there's an interpreter, and there is an output. So from the source code to the interpreter to the output. So anybody who has an interpreter on his machine can simply run the source code and get the output. However, in a compiled language, you need what is called a compiler, which will create the source code into an object code. And then that object code is run by the executor, which will create the output. So therefore, whenever you are running a compiled language like C++ or Java, you will get a source file and you'll get an object code file, and then you execute it and you'll get the output. So this is a very important difference between Python and languages like Java and C++. In Python, you run the code one by one. You don't need a compiler. You just need an interpreter. However, there is one disadvantage of using a language without a compiler. The point is that when I'm writing a program in say a compiled language like C++, what I will do is I will take the source code, convert it into the object code, and then give the object code to whoever wants to execute it. I will not be giving the source code. The source code is in human readable form, but the object code is in a camera on. Camera on है, camera on है यार. So, the source code will get into interpreter and the output will come, and in a interpreted language, the source code is readable form, but in a compiled language, the object code is not a readable form. Therefore, if I want to protect my source code, if I want to keep my source code secret, I will not share my source code with anybody. I will simply give them the object code, and anybody who has the object code will not be able to read my program. That way, I can keep my program a secret. However, in a language like Python, since you are giving the entire source code to the person who is executing it, he can read the entire source code. That means there is no secret. Your entire program is available to the person reading it. This is the important difference between a compiled language and a interpreted language like Python. Okay. Now, the other point I said is open source versus proprietary, also free versus paid. This is a very confusing topic, and many people don't understand the real meaning of open source. Open source does not mean free. I have given the example of a cake. Suppose somebody bakes a cake for you and gives you the cake free of cost, right? So you have not paid any money to the person who made the cake for you. The cake is free. And now, when you ask that guy to give the recipe of the cake, he refuses to give you the recipe. So this cake is not open source, even though it is free, right? On the other hand, suppose somebody gives you the recipe of the cake. He doesn't give you the cake. He gives you the recipe. Now you can, using that recipe, you can make the cake on your own. Therefore, it is open source. Even if he says, okay, I'll give you maybe the recipe of the cake for 100 rupees, you have paid money for the recipe. Even then, it is open source because you have got the source code or the ingredients or the recipe of building that cake. What are the advantages? Now, what you can do is once you have the source code, once you have the recipe, maybe you can modify it. Instead of a chocolate cake, maybe you can build a vanilla cake or a strawberry cake or some other cake. So that way, this is the difference between open source and proprietary. If the person who's writing the program or the source code is giving you the source code, in the source code format, it is open source. However, if he's giving you the source code in a compiled format, which you cannot read, which you cannot change, which you cannot alter, it is proprietary. I hope this is clear. So the next concept is portable. Portability in relation to software indicates how easily an application can be transformed from one computer environment to another. Therefore, if your program can run on a Windows machine, on an iOS machine, on a Linux machine, on an Android machine, then to that extent, your program is portable. However, if your program is not able to run only or able to run only on certain machines and not on other machines, then it is less portable. So Python is a highly portable software or a programming language. Then the next comes is dynamic typing or dynamic binding. This is something which I will explain at a later stage because typing is one of the most important concepts in computer programming, which many people don't understand, and especially people who don't have a background in a scripted language like Python. Suppose you have learned C++ or Java and you have never worked with a scripted language, you may not realize that how difficult or how easy it is to work in how difficult it is to work in a language like C++ and how easy it is to work in a language like Python. So I'll try to do this thing. Okay. So dynamic typing is done. Then next is automatic memory management. So this is also another concept which I will try to explain. Python interpreter does automatic memory management by allocating memory when objects are created and reclaiming them objects are no longer in use. One of the biggest problems with using a language like C++ is that the programmer is expected to take care of the memory. Now, whenever you write a program, whenever you create objects, whenever you create classes, whenever you create functions, then those things need to have memory. Now, to allocate, suppose you're writing a list or a tuple or whatever, you need memory. So you need to allocate parts of the memory to that particular object. Now, when that object is no longer being used, the compiler in a language like C++ has to be specifically told that this particular object I am not using anymore. I don't need it. So you can destroy that object and reclaim that memory. This is what is happening in a language like C++, which does not have automatic memory management. On the other hand, one of the beauties of Python is that there is an automatic memory management, and you as a programmer don't have to worry about allocating and deallocating memories for objects. It is taken care of by the interpreter or by the Python program. This is done through what is called a garbage collection. So if any computer science literature you come across this term garbage collection, don't get worried. Don't think it is some garbage. It simply means that whatever memory has been allocated to a particular object, once that object is not being used by the program, the interpreter will automatically destroy that object and reclaim that memory. That is why it's called garbage collection. Java also has a garbage collector. So this is the difference between C++ and Java. Java has a garbage collector unlike C++. And C does not have a garbage collector. So I hope this is clear. Okay, I'll skip this. Okay, I'll skip this. Jupyter Notebook as a client server application, this I've already explained. One needs to run a server, Jupyter server in this case. The server may be run either on the local machine or on remote machine. I've already explained this to you. If you're using Google Colab, then the Python server is running on the Google machine. But if you're using a Jupyter Notebook, then the Python server is running on your local machine. And you can make out the difference by looking at the address bar of your web browser. If it is having something like localhost something something, then it is running on your local machine. But if it is having a proper address, IP address, or this is like collab something or google something, then you know it is running on a remote machine. All right. So, okay. Now let us come to real Python. You can use Python as an interpreter, as a calculator. I will show you. You can use the Python interpreter as a calculator. As you type in mathematical expressions, results are displayed on pressing return. Operators plus, minus, multiplication, and division. So there are, we are talking about 4 operators: plus, minus, multiplication, and division. Apart from this, there is another operator called remainder, which is a double forward slash. I will just show you all these things. Let me go back to my this thing. Let me type first. Let me show you. Now another thing. If you use a hash, like I've used a hash. If you use a hash, this is a hash. Hash is like this. This is a hash. If you write the hash as the first letter on a line in a cell in Python, then Python interpreter understands that the rest of the whatever you write is a comment, and Python will simply ignore whatever you write. So, right, let me write. So I write hash. Right, let me write hi there. Suppose I write, and I run this. Nothing else. See, now this is 3. If I run it again, just let me. So let me run it again. When I run it again, this 3 will become a 4. You might have noticed this has become a, you can see that this has become a 4 here. Then let me run it again. It has become a 5, like that. So what is happening when I am doing a, when I write a comment like this, nothing happens. So if I write use plus or, and I write 2 plus 3 and I run, I get the output 5. So if I write 2, or rather 6 divided by 3, I get the output 2. Now you may ask, somebody will ask, in fact, I asked this question to myself, that I wrote 2 plus 3 and I got 5. Then I wrote 6 plus 3 and I got 2. I did not get 5. Why? The reason is that there's a concept in programming language called standard output. Standard output. So here the standard output is your browser. The standard output, there is a standard input, standard error, and standard output. There are 3 things. Let me write them. One is standard input. The second is standard output. Let me write std output. And the third is standard error. So what is happening here is that when I write this second command, this output is going to the standard output, which here happens to be the browser. The output of this command is not going to the standard output. But suppose I want the output of this command also, then what I can do is, let me just read them. Then I have to write print 2 plus 3, 6. So I should get something from this line of code and something from this. Let us see how it happens. So we are getting 2 outputs, 5 and 2. So this 5 has come from this line and this 2 has come from this line. So the output 2 plus 3 is not going to the standard output. To bring it on the standard output, we use what is called a print command. The print command is print. It is a print. This is a, so let me say print command. Print command is print, and then brackets, you write whatever you want to print, you have to write inside. Okay, so this is, I hope this is clear to you. So let us go back to our presentation. So I hope this is clear, but let me show the things again. So we can show other this thing also. Suppose I write 8, 4 and I run it, I will get 32, because the asterisk sign in Python means multiplication. Similarly, but if I write 8, oh sorry, then I will get, I will get 1. Why? Because when I write 8, when I write 8, double forward /7, the output will be the remainder, which this case is 1. So I hope I've explained similarly the plus sign, the minus sign, the multiplication sign, and the division sign, and the remainder sign. There's one more called exponential. Let us show that also. It is double asterisk. So 8, 2. it is 64. So when you write double asterisks, like this, there should be no space between the two asterisks. If I was to introduce a space between, suppose I put a space between them, then this will create error. This invalid syntax. So the two asterisks must not have any space between them. If I do it, that's fine, 64. So I hope I have explained what are called the operators in Python. So let us move ahead. And okay, you can use parentheses for grouping. Let me show you an example of that also. Suppose I want to multiply 6. No, so let me show you. If I write 6 plus 2 into 8, now, as you all know about BODMAS, the multiplication will take precedence over addition. So the answer should be 8 into 2, 16 plus 6, 32, 22. That is what we get. But suppose we want to add the 6 and the 2 together. So what we'll do is we'll put it in bracket like this. Now we'll get 6 plus 2, 8 into 8, 64. That is 64. So therefore, parentheses can be used like normal mathematics to change the order of operation. So if you want the addition to happen before the multiplication, if you don't want the 2 to be multiplied with the 8, but rather you want the 2 to be added to the 6 first and then multiplied by 8, then you put a bracket around. You can put as many brackets as you want. It's not a problem. You can do one more bracket. But if you like this and you run it, it will create no problem. However, suppose you forget to put this closing bracket. Now, Python, any programming language is very unforgiving. Let us do it. There's an error. Unexpected EOF while parsing. That means that Python is expecting something which is here. If I put the thing again and I run, I'm fine. So this explains the operator. Let us move ahead. Leave this. Let us talk about Python keywords. Now, whenever you write a program, it goes to the interpreter. The interpreter wants to follow certain rules. So what it does, it uses what is called keywords, which will give hint to the program to do something or not to do something, right? I will explain this to you, but let us first, see all the keywords in Python. Let us see. So it is import keywords.kw list. Let us do it in our listing. So let me write keywords dot it's not keywords, it is keyword KW list. Let me run this. Let us see what happens. So these are all the keywords I have got in Python. So if I see that these are all the keywords, I think there are 22 of them. I'm not too sure, but they can change over time. So false, none. Yeah. So false, none, true, and as these are all keywords. Just one sec. So these are all the keywords in Python. The importance of keywords will become clear to you once we go into the detail. Let us move ahead. Now let us talk about what is called an identifier in Python. Now we'll talk about this later. Let's go further, and let us go further, and let us first understand the concept of a variable. This is a very important concept in Python called a variable. So let me create a screen. Variable. Like in algebra, if you have done high school mathematics, you must have used things like x, y, z, etc. What are these? These are variables. So you might write if x plus 3 equal to 5, then what is x? Then obviously x is equal to 2. So x is a variable. Similarly, in Python also we use what is called variables. This is a very important concept in Python, and this is how it differs from a language like C++ and Java. I will just explain. So the important thing to understand is that in Python, whenever I write, suppose x equal to 5. Now in mathematics, this would mean that the variable x has become equal to 5. And suppose, but in Python or in any programming language, this equal to sign is not the equal to sign, but rather it is called the assignment sign. It is assigned. That means that this is actually like this, x 5. That means the number 5 has gone into x. So you can think of x like a box. Suppose it's a box like this. Box. And this 5 has gone inside the box. So whenever you see x equal to 5 or y equal to 7, this means that there are two boxes, one box x and one box y. And this box x contains number 5 and the box y contains number 7. Okay. Now, in programming languages, the data, so in programming, in computers, there is what is called memory. And the memory has got data inside. So if you talk about any memory in a computer, there are two things to the memory. What are those two things? Suppose this is a memory. This is a memory. This is a piece of memory. This is a box which can store something. So there are two things to that memory. The first is the address of that memory block. And the second is the contents of that memory block. So first is the address and second is the content. However, in languages like Java and C++, there's a third thing called the type of the data which that memory can store. The type of data which that memory can store. So you have to tell this interpreter that what kind of data the memory can store, right? In my book, I have given this, but in Python, the type of data is not required. Therefore, in a language like C++, a memory is like a box. And that box has a type. So I have given that example that it could be, for example, a shoebox or a matchbox. Now you cannot use the matchbox to store shoes, and normally you cannot use the shoebox to store matches, or you cannot do that. So therefore, in C++ and Java, not only does the memory have an address, not only can it have content, but it also has a type. However, in a language like Python, the memory does not have a type. So you can think of the memory like a price tag. For example, you go to a store and you want to buy a coat, and on the coat, there's a coat here. Suppose there's a coat, and on the coat, there's a price tag, and there's written 100 rupees on it, right? So you can remove this, you can cut off this price tag and put it on a pant. And a pant is a different data type than a coat. That means that the same box can contain a coat or a pant, or rather the same tag can be tagged to a coat or a pant. That means the type of data is not important. So now what does it mean practically? This practically, it would mean like this, that suppose you want to have a variable called x. Suppose you want to have a variable called x, and you want to store an integer in it. An integer, as you know, are numbers which do not have decimal. So integer -1, 0, 1, 2, these are called integers. On the other hand, numbers which are having 1.23, these are called floats. So computer programs differentiate between integers and floats. Similarly, you may have suppose a b c or a x b y. So what is this? This is what is called a string, a sequence of digits or letters or numbers. This is called a string. So I'm giving you example of three different types: integers, floats, and strings. Now, if you want x to store an integer in a language like Python, you will simply write x equal to 5. However, if you want to store an integer in a language like Java, then you have to write int x equal to 5. That means if you don't write this int in front of the x in a program like Java, the Java compiler will not allow you to compile that language, because the Java compiler, before it can store this 5 into x, it wants to know the kind of box or the type of memory which exists. This is a good thing and a bad thing. What is a good thing? The good thing is let me say what is the bad thing. Bad thing is that the programmer has to write int before the x every time he wants to do this thing. The other bad thing is that once he has created a box of type int, he cannot store a string in it, he cannot store other types of data in it. He may be able to store certain types of data, other data, but mostly he cannot. However, in Python, if you write x equal to 5, it's okay. And next line, if you write x equal to 5.6, also it is okay. If next line, if you write x equal to quote ABC, let me just clear the screen. In Python, strings are written in either single quotes or double quotes. So you can write x equal to ABC, or you can even write x equal to ABC. So Python will allow this. I will show you. Let me just take you to this thing. And let us see this. So let us write x equal to 5, and I write print x. So I have written two lines over here. The first line is x equal to 5, and the second line is print x. Let us see what happens. I'm getting a 5. You can see I wrote the first line x equal to 5. This is the first line. And I wrote print x and I got an output of 5. Okay. Now, suppose I write x equal to, 5. In the next line, I decide x equal to ASS. So what I have done, now this ASS is a string. Now let me show you. Is a string. Okay, now let me run. I get ASS. So therefore, in the first line, let me just expand it. Therefore, in the first line, x was a box which contained an integer 5. But in the next line, x became a string which contained a string called ASS. So this is allowed in Python. This you cannot do in language like C++. So if you had written, say, type x, not type, int x equal to 5, and then in the next line you write x equal to as, the compiler will not allow you to do this in a language like Java or C++, because Java and C++ have fixed the type of X, the type of the variable to be int. So they will not allow you to put anything, or rather most of the things except an integer inside X. However, in Python, you can do it. You can put a integer, you can put when I'm saying put, I'm basically saying X equal to 5. So always remember, whenever the sign equal to is there, it is assignment. So whenever you see equal to, think of an arrow in the backward direction. So that means that you can put an X inside, 5 inside X, you can put an S inside X, you can put anything inside S. Because X is not a box like in C++, but X is like a price tag which you see in a store, which can be taken out of everything, put onto anything. Balaji, let me stop for 2 minutes here, and let me just understand whether I'm going good, bad, average, whether you're understanding what I'm saying. I don't want to go on endlessly without the people understanding what I'm saying. Am I going too fast? Am I going too slow? Tell me, Balaji.
Yeah, so I think whether you are going fast or slow, only the user can tell about it. But I think it was going pretty well, and the quality of sound and videos are absolutely awesome. So there's no disruption in between. Users, if you can give your feedback here on the right side, if you want anything, please let me know. We can handle your queries, and we can have a separate question answer sessions. Once the session is over, after that we can have a separate question answer session. Okay. Wonderful. I think it's a very plus feedback, sir. Thank you. You can continue. No problem. Oh, you need to unmute yourself, sir. No, you are not audible.
I have tried to explain to you the concept of type. Now, data in a programming language is of different types. And why it is important, I'll tell you. Now, suppose I write X equal to 1 plus 1. Now the let me just expand this. So what the interpreter needs to understand, कि आप चाहते हैं, what do you want? What is this 1? So when I write like this, there is this, you see, there are 3 things. 1 plus 1. So these are 2 numbers, and they are joined by a symbol of positive, which is an operator. So this is the binary operator. Why it is a binary operator? Plus is a binary operator because it is using 2 numbers on both sides of it to commit to do the process. By the way, plus can also be a unary operator. I'll give an example. Wait, I'll give an example. You can write X equal to plus 1 also. Let us run this. And I write print X. So I get 1 again. So here 1 is a unary operator. Here, here plus is a unary operator. So you need to, this is a very important concept of unary, the spelling I am not sure, or the binary operator. So unary operator is something which can act on a single number or a single piece of data, whereas the binary operator needs 2 symbols or 2 pieces of data to operate. For example, multiplication has to be always a binary operator. You have to have 2 numbers to be able to multiply them. Similarly, division, similarly exponential, similarly remainder. So you cannot, if you write something like, let us say like multiply into 1, this will throw an error, right? But if you write 2 multiplied by 1, that's fine, you'll get 2. So therefore, multiplication is a binary operator. I hope I'm able to explain to you the difference between a unary operator and a binary operator. Now, connected to this is the concept of which I'm moving a bit ahead, called operator overloading. It's a very simple concept, sounds very complicated. Operator overloading. What does it mean? Operator overloading means that the operator, rather the symbol, the positive sign, the plus sign, will look at the two pieces of data on which it is operating and accordingly decide what to do. I'll give an example. Now, print x. Suppose I write y equal to now what will happen? Suppose I write print y. Now let us run this. So in the first case, let us remove this line, is confusing. Let us run it again. So in the first case, in the first wait, print, wait. Let me write again. X equal to 2 plus 1 print x. And let us run it again. So in the first case, let me just magnify this. Now, what is happening here? Here it is x, the operator plus is acting like your normal mathematical operator because it can see a number on its left and a number on its right. So it adds a 2 and it gives you an output of 3. Right? However, when I write y equal to 2 plus 1, then what is this plus sign doesn't see a number 2 on the left and a number 1 on the right, but rather it sees a string 2 on the left and a string 1 on the right, and it doesn't add them mathematically, but rather what it does is it concatenates them. Concatenate. That means it puts them together. All right. Now let me just show you some problems. Now suppose I remove this. Now what am I doing? I am trying to add 2. Let me just show this. See, what I've done is I put a single quote around the 2, but I have not put any quote around the 1. So what I'm trying to do? I'm trying to add a string to a number. I'm trying to add the 2 to a 1, but the compiler is confused. What should it do? Should it print an output of 3, treating 2 as a number, or should it print an output of 21, taking 1 as a string? The compiler is confused. The compiler will not allow, or rather the interpreter will not allow this kind of mixing. Let us run this. There's an error. See, the first part, this is printed fine, but there's a type error. You can only concatenate string, not into string. See, just if you see this, it is writing. You cannot. So it has used the same word which I mentioned, concatenate. Concatenate means putting 2 strings together. So here what I'm doing is I'm trying to add the 2, which is a string, to 1, which is a number. So I cannot do it because I can only concatenate the 2 strings. I cannot add a string, but certain languages like JavaScript, they allow even adding of a string to a number, but it will give you variable results. It will give you unpredictable results. In some situation, it might give you 3. In some situation, it might give you 21. So if so this is the difference between what is called a strongly typed language and a weakly typed language. Let me just explain. So there are 2 types of languages. One is called strongly typed language. Other is called a weakly weakly typed language. So Python is a weakly typed language because it allows the as here, it allowed the as to be put into X. It also allowed the 5 to be going into X. But Java and C++ are strongly typed language. And JavaScript, just remember, Java and JavaScript have nothing in common except the name. Otherwise, people think that JavaScript is related to Java. JavaScript is not, has nothing to do with Java. It's a totally different language. So JavaScript is a weakly typed language. In fact, it is even more weakly typed than Python because it allows you to even do things like adding a string to a number, which Python will not allow. All right. So I hope this part is clear. Let us move ahead. Okay. I have explained this concept. I hope it is clear. Assignment. Right. Note that assignment of a data like string, integer, float, etc. to a variable is different in C++ and Python. I have already explained. In C++, you have to write int x equal to 5. But in Python, you can simply write x equal to 5. So if you are coming from a background of a strongly typed language like C++ or Java, and you see a statement like int x equal to 5 or rather x equal to 5, you may think, what is going on? What kind of data is there in X? So what the Python interpreter is very smart. What it will do is, it will look at X. And sorry, it will look at 5 and then see, okay, the type is 5. So I can just show you how it works. So let me just move this error. And now let me write print so this I am printing the type, or let us see what happens. So it is a class int. Now to make it clear, I can write x comma or rather. So just one second. So what I did, I've written this print statement. I'll explain later to you. You can print a number of things by separating them by comma. So I've printed this x, this thing. This is a string. This will be printed as it is, and I printed the type of x, which is int. And we can if you're getting confused, we can skip this also. We can just write type this thing, and we'll get a simple x class int. Now let us write print type y. It is showing class str is in Python is string. So why can so when you get an output class string, that means that y contains a string and x contains an integer, right? So what the Python interpreter is doing, it is looking at the number which has been assigned to it, which here is an integer, and if you ask the type of x, so what does interpreter, he says, hey x, what type are you? The next will say, hold on, let me see what kind of data I contain. It looks inside its box and sees that there is an integer 2 plus 1 3, and it tells the interpreter, boss, I am an integer, I am not a string. However, when the same interpreter goes to y by giving the statement print type y, then y says, hold on, let me see what I contain. I have a 2, and I have a 1 inside me, but this 2 is not a number 2, it is enclosed in single quote, so it is a string. This 1 is also not a number 1, it is also enclosed in 2 in a single quotes, it's also a string. So I am concatenating the 2 and the 1, I am containing a 21, which is a string. And therefore my type is string. So this is the difference between, I hope I've explained the concept of type to you, and the strongly typed and weakly typed. And I've also explained the concept of what is called operator overload. So let me write the concepts I've explained. I've explained the concept of strong versus weak typing, and I have also explained the concept of operator overload. And let me repeat this concept again. Operator overload means that an operator can behave differently in different situations. The same plus sign, let me say, the same plus sign, if it has a 1 and a 2 around it, it will give an output of 3. But the same plus sign, if it has a 1, I'm putting double quote on purpose, and I suppose A, it will give an output of 1A. Let us see this also. So we can replace this 1 with the X. Let us see what we get. So see, we got 2X. So the 2 has been, let me just show you properly. So what has happened here is that this 2 has been concatenated to this X to give you an output of 2X. And here the 2 has been added to a 1 to give you an output of 3. All right. So I hope this is clear. Let us move ahead. Assignment is clear. As I let me again tell assignment. Assignment is in Python is the equal to sign. A equal to 3 means that you are assigning a value of 3 into A. So assignment, always remember assignment is this. If I write X equal to 3.7, then it means that X is getting a value of 3.7. By the way, let me use a float also. Let me just show you another this thing. Let me just clear up. Let me comment out this line. So when in programming, there's a very common concept called commenting out. Commenting out. Commenting out. So what I have done, I have put a hash sign before this line. This line will not be executed. So X will continue to be 5. Now let me just make it 5.9. And let me write print sorry. So what I get a float. Let me show you. So when I write X equal to 5.9 and I ask the compiler or the interpreter to print the type of X, I'm not getting an int, I'm getting a float, because the Python interpreter understands that 5.9 is not an integer, but rather it is a float. Now there's another thing which the interpreters are very smart. Let me show you. Now let us say we are adding 5.9 plus 3. Let us do it. And let me write the print X. So I'm getting 8.9. Now something very interesting is happening over here, which I don't know whether you have noticed or not. What I'm doing, I'm adding a 5.9, which is a float, to a 3, which is an integer. So I'm adding a float to an integer. Now you will say that I only told you a few minutes back that you cannot add different types of things, but there are certain operations in programming languages which are permitted. And one of them is adding a float to an integer. You can add a float to an integer And when the interpreter sees this kind of a situation, when it sees 5.9 plus 3, what does it do? It will first convert this 3 into a 3.0. That means it will convert the float into an integer into a float, and then it will add these two together to give you the output of 8.9. And that is why the type of x is a float and not an integer. So there are two things in it. One is called a broadcasting. Other is called a narrowcasting. These are concepts which you really did not need to know, but I'm just telling you because it has come on the way. Narrowcasting. Now this change. Now first, let me tell you what is casting. This is a very important concept in computer science called casting. When you change the type of an operator from one type to another type, what you are doing is you are casting. You are casting the operator from one type to another type. Now, when you are adding a 5.9, when you're adding a 5.9 to a 3, the compiler actually has two options. The first option which it used was to convert the 3 into the 3 which is an integer into a float, add the two float together and give the output of 8.9. However, there is a second possibility. The second possibility could have been that it could have, I will just show you again, the second out was that when you're adding 5.9 to 3, the second possibility could be that it converts this float into an integer, then it will become 5 and add the 3 and give you an output of 8. So in the first case, what is the interpreter doing when it is adding the 5.9, converting the 3 into 3.0? When it converts the 3 into a 3.0, which means that when it converts the int into a float, what is the compiler doing? It is broadcasting, because the integer is a subset of float. That means that every integer is a float, but every float is not an integer. So if you write them in terms of Venn diagram, if you write them, this is suppose the set of floats, then the set of integer would be something like this. That means that every integer which is in this box, in this circle, is inside the bigger circle of float. So what you are doing, you're converting the integer into a float. You're converting the 3 into 3.0. So this is broadcasting. However, when you convert the 5.9 into an integer, then you are doing what is called narrowcasting. So as you can make out, narrowcasting can lead to loss of data. Narrowcasting can lead to unpredictable results. Therefore, you see, because computer science is a very precise, discipline. Computer science is a very precise discipline. It does not want the same input to give two different outputs. Therefore, in operator overloading, normally the compiler will permit broadcasting, but will not permit narrowcasting implicitly. The term is implicit. There are, let me write the term again. The terms are, there are two terms, explicit and implicit. So when I added a 5.9 to the 3, what the compiler did, it implicitly converted the 3 into 3.0. That means it did not ask me, it did not seek any instruction from me, and it simply converted the 3 into a 3.0 without my asking. This is called implicit type conversion. So therefore, normally when you are going from a narrower type to a broader type, the conversion is implicit. However, when you are going from broader type to narrower type, generally you have to go for explicit type conversion. I hope I'm clear on this. Balaji, let me stop again. And let me just, because this is an important concept of type conversion. Is it clear, Balaji? Balaji?
Thank you.
Balaji, is it clear?
Yeah, very much there, sir. Yes. Am I audible?
What I have said is, is everybody able to follow what I have said? Assignment? Okay. Variable identifier, I'll skip this. And
Yeah. Team, if you have any questions on variable and identifier, please.
No, variable identifier I have not really explained, Balaji, because that is slightly more, we will do it once we go further in the course. But variable one should understand.
Yeah, there is one user in asking for another example of broadcasting.
Another example of broadcasting. It is there in when we cover object-oriented programming, when we create classes, that I cannot think of, you see, the broadcasting happens in simple operators like plus, minus, this thing and all. And it also happens in what is called the user-defined variables like objects and classes. So I will give you those examples when I go into class, when I go into object-oriented programming, there will be number of examples. But right now I am not able to think of any, but let me go over the thing again. Let me think, it will take some time and I can give more examples. But the examples which I have given, I hope you have understood. So shall we go to the next chapter, Balaji? Hello, Balaji?
Sure, sir.
Okay. So I'm moving to chapter number 2 of my book. So these are the concepts. I'm going to talk about built-in data types. I'm going to talk about sequences and containers. And I'll talk about the concept of mutability, object ID, typecasting, implicit and explicit. In fact, I have covered a bit of this. How to provide input to a Python script, explain what are modules and packages, and understanding Python strings, binary literals, and Boolean types. So let me repeat. I'll talk about built-in. This is number 1. I'll talk about sequences, number 2. I will talk about containers, number 3. I will talk about mutability, number 4. I will talk about object ID, number 5. I will talk about typecasting. I will talk about implicit. I will talk about explicit. I will talk about input to a Python script. I will talk about modules. I will talk about packages. I will talk about binary literals, and I will talk about Boolean. So there are 13 concepts. Let me just, write them again. So I'll talk about built-in. What is the built-in? These are important concepts, therefore I'm taking time on it. Then I'll talk about sequence. This is number 1. This is number 2. Then third, I will talk about containers. Then I'll talk about mutability. Mutability means basically in Angrezi, in English language, mutability means something which can be changed. And number 5, I'll talk about typecasting. This I've already discussed to some extent. Typecasting. Then 6th, I will talk about implicit. 7th, I'll talk about explicit. Then 8th, I'll talk about ways of giving input to a Python program. And then 9th, I'll talk about modules and packages. 9 and 10. Then I'll talk about binary literals and I'll talk about Boolean types. So like this, these are the topics I will discuss today in chapter number 2 of my today's class. Okay. So there are two basically types of data in Python. One is called simple, other is called compound. Let me repeat. We are moving on to a thing called data types. I have given you example of some simple types like integers, floats, complex number I have not given example, Boolean, I have not given example. String, I have given example. So out of these 5 types, int, float, complex, bool, and string. So these are the 1, 2, 3, 4, 5 types of data, simple data in Python. I've given an example of integer, I've given an example of float, and I've given an example of string, but I have not given you the example of bool, and I have not given you the example of complex. Complex we can leave out, but bool we need to know. Okay. Apart from that, there are some other data types which are called containers, right? So containers are data types which can contain other data types. But both simple and compound data types are built in data type. So I will explain this. Let us move a bit further. If you look at the data types in Python, this is a figure from my book, data types. So this is numbers, which can be integers, float, complex, and bool, by the way, is a subset of integer. I'll explain. And none is a data type, which is not 0, by the way. None is a data type in Python. I can explain. Sequences are strings, tuples, and lists, sets, and mappings, which are dictionaries. Now, just let me go a little bit of difference between a sequence, a set, and a mapping. A sequence is a data type in which the order of the items inside the data or the type are important. For example, in Python, there is called a string. Suppose string A, B, C. Now, this string A, B, C contains 3 letters A, B, and C. But if I write B, A, C, then this is a different string than this, because even though the 3 letters are there in both the data types, however, the order of the letters in the second is different. And strings are sequences. Therefore, in Python, ABC is not equal to BAC, right? However, sets and mappings are data types in which the order of the data is not important. Mappings, sets, you understand, for example, if the sets in Python are used with curly bracket, no, they're used with, sorry, but they're used with round brackets. So if I write 1, 2, and 3, let me just show it to you. It's a better way of learning than just talking theoretically about it. So let us just do it. Right. A equal to so what I've done, I have let me just explain. This is a variable A. It has been assigned this. This is what is called a list in Python. This list has 4 items. The first item is a string. The second item and the third, the second, the third, and the fourth are all numbers. They are all integers. So this, by the way, this is the standard way of writing a list in Python, and they all have an index. In Python, the index always starts with 0. That means this first item has an index of 0. This has an item index of 1. This has an index of 2. And this has an index of 3. Now let me just write print. So what I've done, I'm printing the type of a. Let us see the output we get. Class list. So if you can see, A has been assigned 4 items covered by square brackets, and this is a list. What is this? This is a compound data type, but it is a compound built in data type. Built in means that the Python interpreter does not need any additional information to understand that if there are 2 square brackets containing primitive data or other data inside, then it understands that this must be a list. This is something which the Python knows on its own. It doesn't need to import other libraries. It doesn't need to import other information to understand that these square brackets stand for a list. That is why it is called built-in. And why it is called compound? Because it can contain other data types within it. So therefore, a list has got 2 qualities. The first quality is that it's a built-in data type. The second quality is that it's a compound data type, right? Should we stop here, Mr. Balaji, or should I continue?
Yes. No, we can break here, sir. No problem.
Because making it too long will make it monotonous and boring. So I think this much of thing is enough for a day one, and we can go on to these data types. But if people have understood this much, you see, let me just add one more thing. One of the biggest problem for a newbie or somebody who's learning a programming language for the first time is how to install the programs. So the Jupyter notebooks, everybody should be able to install on their laptops. There is only one problem which I cannot explain now, but you see, whenever you are installing a program like Jupyter Notebook, it has to be added to your path variable. So I don't know whether Balaji, do they understand the concept of the path variable?
No, sir, not yet.
So,
not many. There are some absolutely beginners are there.
Right. So basically, a Windows machine has to know where to find the particular interpreter, the particular program to run that particular thing. Like because those who are coming from a Windows environment, they are used to what is called graphic user interface and double clicking, right? So when you are in a Windows machine, what you do, you go to the particular program, you double click it, and the Windows operating system is able to run the program. But this was not always the case. Many years back, when you used to have what is called command prompt, the interpreter or the Windows machine had to know how to open that program, right? So when suppose I have a command prompt like this, suppose, let me just show this to you. This is the command prompt. Now, this I write Python. Let me run it. So let me just show you. So I ran this. This is the command prompt made by this sign, and on front of that I wrote Python space _version, and I got the output of Python 3.9.7. This might be different on different machines. If you have an older version, this might be 3.8 or 3.7. But the important thing is that when I run this Python over here, then this command prompt has to understand what it means. Now, how does this command prompt know what it means? Therefore, what it will do is, in every Windows machine, there is a system variable called path. I will just show you where it is. And in the path, there are a number of paths separated by semicolons. Path 1, path 2, path 3. And so what the Windows machine will do, it will look for this Python interpreter in this path variable. If it is not able to find this Python in the path variable, it will write something like command not understood or something like that. So therefore, it is important. I'll show you how to, yes, let me just show you. To do this thing and yeah. So environment variable is here, and let me just, so you can see here, this is the path variable. So on, because I'm not logged in as a administrator, so these new and edit are grayed out. So you can add the path to your Python interpreter in this using edit. Now, how exactly that is done is not possible for me to explain right now. So I think some of you, if you do your own research, you will be able to. Otherwise, the other option is when you're installing the Anaconda on your machine, it will give you an option to add to the path variable. If you check that option, then the Anaconda downloader on its own will add the path to the Python interpreter to the path variable. I don't know whether I've made myself clear or not, but I think we'll stop here. If somebody has a question, we can ask. Otherwise, we stop. Balaji, over to you.
Yeah. So, sir, you can drop off. We can still continue for 10-15 minute time because we'll have some small work left for us for the day. So
I'm good. I can wait for if you want something to ask.
It's a long day for you, sir. It's almost.
No, it's okay. But are there any questions, any reactions,
any question from any one of you, ladies and gentlemen, boys and girls? You can unmute yourself now. Let me allow you to unmute. Give me 1 second. Yeah, you can unmute now and speak if you want. Or you want to type, feel free to type on the chat window.
Sir?
Yeah, please.
Sir, I have a question. Sir, if we make an application using Python, is there a way to hide the source code?
Sir, you are on mute. Sorry for that.
Yeah, you can do it. You can do it. You can hide the source code. But you see, for everything which you do, somebody has a. So there are, in fact, there are programs which can even decompile programs of C++ and Java also. So both ways it works. You can hide the source code. Yes, you can. But there are programs which can decompile the compiled program, not only of Python, but even for Java and C++. In fact, we in our when we are analyzing the source code of malicious files which are in exe formats, we regularly use decompilers to decompile the compiled program. We may not be able to get all the data, but we are able to get certain important data. For example, if the program is taking you to a particular website or a URL, we are generally able to locate that. I hope I've answered your question.
Yes, thank you.
Pulela Giridhar is raised hand. I think Pulela Giridhar wants to ask something.
Hello, sir.
Yeah, Pulela
Sir,
Giridhar.
Can you please explain like how to access your books?
How
that we can refer the access your book.
Oh yeah,
Python
okay. Yeah. I forgot that. Yes. So this is my you go to Google. I'll just show you, and you type. I'll just do it for you. AG999. You go to Google and you write GitHub AG999 Git. And use this. This is the first. This thing is AG trip. This is my this thing web page. Let me just show you. So this is the GitHub. In fact, by the way, anybody who wants to make a career in programming must know how to use GitHub. If you don't know how to use GitHub, then to that extent you are highly handicapped and you are out of the race. So I advise all youngsters Whether you are going to become a hacker, you're going to become a programmer, or you're going to become a data scientist or a machine learner, whatever you want to do, you must know how to use the GitHub. Yeah. So when you go there, so these are the repositories. So repository means the place where the data is contained. So I'm having how many? I'm having 6 repositories. The first is, I hope it is clear. These are the 6. So this is the first repository. This is number 1. Then there's another one, Jupyter Notebook. This is number 2. Then there's a repository called data. This is number 3. This is a repository called articles, 4. Then images and figures, 5. And then scripts, 6. So these are the repositories. Let me go. This is the one which is important. Book, Python programming language, packages and libraries. So now you can see, now see there is a, if you know this, there are, see there's a blue folder and a white, in front of this. So there is a icon is blue or icon is white. So I just show you. So these 3 icons are blue and these 2 icons are white. The blue icon means it's a directory and the white icon means it's a file. So and then there is a thing called readme.md. By the way, .md stands for markdown. So I have written the readmd, this file, if I click it, this is my this thing. This is the markdown file, the introduction. Anyway, let me go back. Yeah. So online chapters 21 to 25, PPT notes as PDF, book chapters HTML, and for PDF. So online chapters 21 to 25. So these chapters 21, 22, 23, 24, and 25, and appendix, these are there in this folder online, this thing. So I can see 21. It will take a minute to open. Yeah, this is the chapter on matplotlib. It's a very important Python library. So you can download it, use it. This is how it works. So this is matplot. Then chapter 22 is what is called it will take a minute to open because it's on the internet. It's taking a long time. Anyway, so you can do then. The other part is PPT notes as PDF. So what I've done, this is chapter 1 PDF. So this is the PowerPoints of all the 25 chapters of my book. They're available here. I don't know why it's taking so long. Yeah, this is chapter 1. This is the PPT of my chapter 1 converted into PDF. This is chapter 2. This is 10 because chapter 2 will be down here. Chapter 2 is here because because the GitHub thinks that 10 is a number which is smaller than 2. That's why it is showing 10 above. So 2 is here. Then this is chapter 2. You can see this one I showed you just now. Built-in types and all that you can cover. Then there's another book chapters HTML. Now, this is a very interesting this thing. Now again, 10.1 is chapter 10. So let us go for 1.1 Python basics. This is right. Sorry. This has to be. One sec. This is in the. This will wait. This has to be. This is in HTML format. The best thing would be to download it as HTML. Let me save it in a place where I can show you. Let me show download 1.1 Python basics. It has got downloaded over here. This is the one. When I double click it, it is an HTML file. So this is chapter 1, and there are some very good examples are there. For example, commenting and this thing. If you go through this is an HTML format. So you go to my this thing, and these files you have to download first, right? Download the file, and if you know how to use Git commands, you can download all the 25 files in one go also, right? Let me just show you. I have not used it. Yeah. So these chapters you can download, and they contain excellent examples. Like this thing for chapter 1, right? So if you read this is a very good way of, if you read this whole thing, right, to see the list of keywords. In fact, you can then simply copy. Suppose you want to run this command, you just copy from here, or not write it, and you can copy and you can run it. But similarly, chapter 2, you can see chapter 2 will be somewhere down. This is chapter 2. Have to again. No, sorry, this is that. Chapter 2 is here. This HTML. Again, you have to download. Save it as this thing, and then open chapter 2. This is chapter 2. So, does that answer your question? I hope you are able to use this thing. Balaji, we can do one thing. If your students want, you can create a Telegram channel, because if there are too many, if there are few, you can create a WhatsApp channel, and then people can post their questions in that channel, and we'll try to answer some of their queries, because it is not possible to take questions one by one for so many people, right?
No, you can drop off. I can still, take some question, jot it down, and we can have a
Really?
structured answer tomorrow before the session begins.
No, let me go. No problem. People can ask. I'm okay. So there's one message. Can you share your email ID? Yeah, I'm just sharing my email ID is 999 dot. I've entered my email ID. Everybody we can send me a message. No, not a problem. Then what else? What other questions are there? Git and the book link. Mohit. Mail ID. Is it available for Linux, Debian? Yes. This Anaconda runs on Linux also. It runs on Windows. It runs on iOS. Not a problem. Can you once again say your book name, please? So what I can do is I'll just share my book. I'll just share my book link with all of you. This is my book. How do you share the link? Yeah. So, one sec, I'm just getting a copy link. Not gone. Just one sec. I'm just coming again. Balaji, I don't know how to send the link. Balaji?
Sir, you simply need to go to the chat.
Okay, I'm there.
Participant after that chat.
Yeah.
Then from that you have to copy and paste the link. and send to all.
Send to all. That's what is not happening.
To everyone, sir. To everyone option you have to click. To everyone in the meeting.
Chat.
And sir, your email is not visible to everyone.
Which is the person. Okay, this is going to specific people. So how
Yeah.
do I give to
Just
everybody?
click that name, there you will have find everyone in meeting.
Sir, in two there are drop down option.
I think somebody has posted my book.
Yes, sir.
Yeah, I think
Yes.
some smart guy has done it. So thank you, Mohit. So I think I'll stop here. Okay, Balaji. I think
Yeah.
enough for one day. And if you want to create some channel, Telegram channel or WhatsApp group.
It's
yes,
already there, sir. I'll just add you there, no problem.
all right. So people can put in their questions and or mail me a question. And
Sure.
please, Mohit, please put my email ID also 999.anuraggupta@gmail.com. Yeah. Okay. So Mohit has
Thank
put
you
my
so
email
much,
ID
sir.
also.
Thanks for the day one.
All
We'll wait for your next day.
Okay. All right.
Thank you. Hey. So, boys and girls, ladies and gentlemen, you all are dropped out or what? Just hold on, hold on. You're not going to go off now because there will be planning for exams for tomorrow. Just give me 1 second, just a text on the Telegram.